Hey everybody, this is going to be one in a dosage calculation series for these videos, and today we're going to talk about milliliters per hour and drops per minute. Objectives of this session, we're going to do some conversions to figure out milliliters per hour, and we're also going to do drops per minute. All right, so let's start off with milliliters per hour. When you're thinking milliliters per hour, I want you to remember that your answers are always going to end up with volume, which is going to be your milliliters, over time, which is going to be your hours. So just kind of remember that. I've given you an example problem. But first, before we really start getting into the math, we want to look at a couple of different things. So my first thing is I always say, what am I solving for? So we have to read the question and find out, like, what do we want to end up with? So we have 1,000 milliliters of normal saline over 24 hours. Find the pump setting in milliliters per hour. So that is actually what we are solving for, the ml per hour, okay? So now we want to look at, let's just do a little bit of what's really significant and relevant in this question. So now we want to pull out basically what's important that we're doing here. Well, we already said we're solving for milliliters per hour, so that's important, right? I hope you're also looking at the parentheses that tell you how to round, so we know our final number has to be in the 10th placeholder. So what other information is important? Well, I'm already looking at this one and I said, well, I know I'm solving for milliliters per hour, so this must be important, and this item right here must be important. So kind of when you're practicing, I want you to highlight or do some things like that to kind of find out what are you solving for, and then highlight what's important in the question. All right, so kind of this is the same question from the previous screen, but now we're going to start going into some math. Just to kind of bring back what was really important and what we're solving for. We did say we have to round to the 10th placeholder. We're solving for milliliters per hour. We have 1,000 milliliters that we're going to give to our clients over 24 hours. So now we can really start to, let's do some math. So we're going to go ahead and say, well, I'm solving for milliliters per hour. Okay. So now we got to determine how to set up the problem. And there's many ways that you can do this, and there's many ways you can do math. I typically present in a way of dimensional analysis because it has never let me down. A lot of people say, well, dimensional analysis, it's all fractions. I felt that way too because I hate fractions. So I kind of write it visually in a different way so it's not a fraction for me. So now we need to kind of set up our problem so we can do some math. So how do I know what goes on top and what goes on the bottom? Well, milliliters has to be on top and our time has to be on the bottom. So I know we have 1,000 milliliters. Oops. And we know that we have 24 hours. And I encourage you to always continue to write your labels, units of measure. It just keeps things simplified. And you'll see when we get to a little bit more in-depth problem why that works. So really, do you have milliliters? Yes. Do you have hours? Yes. You don't need any more information right now. So now all you have to do is divide 1,000 by 24. So when you do the math, that's going to give you 41.666, and that's where I'm going to stop. Now, remember, what does our rounding rule say to do? This problem wants us to go to the 10th placeholder, okay? So let's just put this down here. This is what we had. Now, when you're doing the 10th placeholder, that's this piece right here. That's the number that you're going to stop at. But what's going to make that number change is its buddy right next to it. So when we're looking at rounding rules, 5 and higher, round up. 4 and lower, round down. So this 6 is telling me, hey guy over here, you got to go up a number. So ultimately what we're going to end up with is 41.7. It's milliliters per hour. That unit of measure or label will be pre-populated for you in your homeworks as well as on your exams. And this is our final answer. Now, if you're needing assistance with dosage and you're writing things out or you're showing me your work, I really do like the final answer to be circled or boxed. That really draws attention to it. But you don't have to. It's just a practice the math teacher taught me. All right, so let's try another problem. So remember, first question you want to ask yourself is, what are we solving for? And what we are solving for is going to be milliliters per hour. So we want to say, yep, we're solving for milliliters per hour. We got that. I'm just going to make a little note over here. That's where I need to end. Now, what's important? So I'm going to pick a different color. Let's do green. Think about this for a minute, and I hope you're saying, well, I know I need volume over time. So I need a number that's volume, and that is that right there. There's your 120 milliliters, and you know that you need time. Well, minutes is time, so that number must also be important. And you also want to pay attention. Just like a good question on an exam, you want to look at what's in the parentheses for things like select all that apply. This question tells me to round to a whole number. So let's set up our problem and do some math. We have milliliters per hour, so we know we need milliliters on top. So that's an easy one. We can go here and put that right on top. And we know that our time, which is on the bottom, is 90 minutes. Here's where this problem gets just a little bit different. We're not solving for milliliters over minute. This is a common error when I look at dosage homeworks. So what you want to do now is we've got to do something with that minute to make it hour. So I hope when I ask you this, you know this right off the top of your head. How many minutes are in an hour? And you are all telling me right now 60 minutes in an hour. Now, some students ask me, well, how did I know to put minutes on top? So let me show you. When you use dimensional analysis, if you set it up right, you can figure out that your problem's set up simply by canceling like items from top to bottom. So, do you need minutes? No, we need hour. So let's get rid of the minutes on the bottom, and remember, whatever you get rid of on the bottom, you get rid of on the top. But we do need milliliters per hour, so I circle those. Just a little habit that you could get into so that way you stay on track with where you're going. Now all we need to do is set up our problem and do some math. So everything across the top stays on the top. Everything on the bottom stays on the bottom. So we have 120 multiplied by 60, and then we're going to divide by 90. When we do the math on that problem, it's going to give us 7,200 divided by 90. Oh, but wait, that's some big numbers and a lot of zeros. And I will tell you, when you start getting into more complex problems, those zeros are a common error when you're putting it in the calculator. So here's a way you can kind of eliminate a few of those. Just like we canceled the minutes, what's on top, if it's the same on the bottom, you can cancel. So we have 2 zeros on top and 1 0 on bottom. The 0 on the bottom is going to drive the bus for how much we can cancel. So if I have like items, let me just get rid of that 0 and that 0. So now we're left with 720 divided by 9. Okay? When you do the math for that, you are left with 80. So our answer is 80. But wait a minute. Let's make sure we round. Always make sure you round. Answers, the question is saying round to a whole number. Oh, it's already in a whole number. So guess what? That's our final answer. No need to round in this problem. All right, so let's do one more milliliter per hour. Now this one's got a little bit more information in it. So remember, the first thing we want to do is determine what are we solving for. So we know that we are solving for milliliters per hour, right? Now, let's figure out what is significant and relevant. So when I'm sitting here, I'm looking at 5% dextrose, 1/2 normal saline, 50 milliliters IV over 3 hours. Whoa, wait a minute. Okay, that's a lot of numbers. But just think about this. Remember, I said it's volume over time. So we know volume is milliliters, so that's important. And we know 3 hours is important. But like I tell you with test taking with regular questions, sometimes we think some other things are important too, but we just don't know yet. So when we're looking at math problems, sometimes you're going to get information that is given to you because it kind of sets the stage for the problem. You're going to see an order for 5% dextrose and 1/2 normal saline. That's a fluid and how it comes, but this has nothing to do with your math. You don't need that. I wanted to make that red. Why is that not red? All right. So, although that's really good information to know, in order to solve, we just need what I've highlighted. Oh, and don't forget, we got to make sure we know what we're rounding to. So now we'll just do some math and get our problem set up. We know we're solving for milliliters per hour. Okay. We know that we have 500 milliliters over 3 hours. And when we look at that, do we have milliliters? Because that's what we're solving for. Do we have hours? That's what we're solving for. We don't need to go any further. So 500 divided by 3 is going to give us 166.666. But remember, got to round. So, and we said round to the 10th, and this is the 10th. So we have to take a look at this. 6 tells me to go higher. So now we're going to have 166.7 milliliters per hour. And there is our final answer. All right, so now let's move on to drops per minute. So a few things we want to remember is that it's going to be, again, volume over time, but this time it's drops instead of milliliters, and it's minutes instead of hours. And I want you to be very, very mindful. Now we're going to tell you how to round in the problem, but just think about this. Whenever you're doing drops, it cannot go to the 10th or 100th placeholder because you physically, I want you to pause the video, I want you to go in your kitchen, and I want you to put 1 drop of water on a small plate, and then I want you to cut that drop in 10 pieces. It just can't be done. So drops will always be a whole number because they cannot be split. All right, so before we do some math, We need to look at what we're solving for. We need to know what is significant and relevant within the problem. One thing when you're doing drops per minute, you want to think about a couple of other things. You got to look at the drop factor. You got to have that drop factor. So we know that that is 10 drops per milliliter. We know that we are solving for drops per minute, and we're going to get into more in the next screen. We know that we need volume, and we know that we need time, and we need to pay attention to the rounding. So this was the question from the other screen. So I'm going to go ahead and kind of highlight that really important information. We did say whole number. We needed our drop factor, drops per milliliter. We know we need time, and then we need a volume amount. Okay, so what we need to do now is look at how we're going to set up our problem. So what are we solving for? Drops per minute. Okay, so now here many students ask me, well, how do I know, again, what goes on top, what goes on bottom, what number do I start with first? When I do drops per minute, my practice is I know I need drops per minute, and I know drops has to go on top. I know I need a drop factor. I start with the drop factor. So we have 10 drops per milliliter. Whoops, let's erase that. Okay. 10 drops per milliliter. That's not all the information that we need to use, okay? Because we don't want drops per milliliter, we want drops per minute. So one thing I do next is you can either go to milliliters next, or you can go to hours next. I like to keep my problems kind of tied together. So I need to find something that I can do with this milliliter, and that's going to be that 850 right there. So 850 has to go on top, and I'll show you why in a minute. And we know that 8 hours then subsequently has to go on the bottom. But we're still not done because we need minute, right? So now you have to convert hours to minutes. And hours has to go on top because we're going to have to cancel. And you know that there's 60 minutes in that hour. So now let's clean up our problem just a little bit. Do we need milliliters at the end of our problem? No, we don't. So let's just cancel those. And do we need hours at the end of our problem? No, we don't need those either because we want minutes. And the only thing you're left with is drops per minute. Now we just need to kind of shore it up a little bit, and this is going to be a good practice for you because you want to get all this mess out of the way because you just want to start multiplying and dividing. So remember, everything across the top and everything across the bottom stay in those places. And I drive you to this because when you start doing more complicated problems like compound problems, for example, micrograms per kilogram per minute, it's going to be very imperative that you keep these things together. So we have 10 times 850, okay? And then on the bottom, we have 8 times 60. So when we do the math for those, what we end up with, and if you don't want me to say it right now and you want to do the work, just go ahead and pause the video right now. Hey, you're back. I hope you got your numbers. Okay, so I got 8,500 over 480. I don't like all those zeros because zeros make me do errors on my math because when I put them in the calculator, I tend to miss one. So I'm going to get rid of a 0. So now I can be left with 850 divided by 48. This is going to give me an answer of 17.708. Okay, but remember, we want a whole number. And a common mistake is a student will see 17 and just go from there. But now that we're doing the whole number, we have to look at the number to its side. 7 and higher makes it go up. So ultimately you will be left with, whoops. Let's erase that. Sorry about that. A little technical difficulty. We're going to be left with 18 drops per minute. Okay, so you look at this problem and it's like, oh my gosh, there's a whole lot of writing here. Let's just chunk it out. Let's look at this. Let's answer our first question. What do we need to solve? And we need to do drops per minute. So drops per minute is important. We need to round to a whole number. We always said we need our drop factor, okay? I need volume and I need time. But wait a minute. Wait a minute. I've got a unit of measure here. I've got a time here. I've got volume here. I've got minutes here. Again, this is a situation where you're given, basically in the first sentence, what is the provider's order? And that is 1 gram of Kefsol every 8 hours. But the pharmacy is going to send it already done up for you in a 50 milliliter bag. And then they're going to tell you it needs to be infused over 30 minutes. That's kind of how it's going to work in practice. So when you're looking at your dosage question, I don't need this gram and I don't need this 8 hours. What I'm really focusing on right now is a 50 milliliter bag of D5W with that Kefsol in it, and I'm going to set the pump to infuse over 30 minutes. Or since we're doing gravity, I know it needs to infuse over 30 minutes, so I have to manually count the drops. So let's set up a problem. We're solving for drops per minute. I'm very habitual, folks, and I learned this the very, very hard way. When I was in nursing school, it took me a while, and somebody sat me down and said, do it the same way every time, and that way you get used to the way you do it. Same thing with your assessments, but that's a whole nother lecture. But so I say the same thing with math. Keep your process the same way every time, and this can help eliminate mistakes, errors, or omissions. All right, so drops per minute. I always start with the drop factor. I always keep my labels. We know we're not done. I know I need a milliliter to kind of go over here, and that is 50. And we know that's going to be over 30 minutes. I'm going to cancel what I don't need, and I'm going to keep what I do need. And now all I have to do is math. 60 multiplied by 50 divided by 30. And when I get that, we get 3,000 over 30. Too many zeros for me. So I want to divide 300 by 3 because that's really easy for me to handle. I can do that division, and we know that comes to 100. So our answer is 100. We're going to take one quick look back up to it. It says, yes, round to a whole number. So rounding is not needed because we are already there. All right, let's do this last problem, I believe, in the drops per minute. Again, want to know what we're solving for. It's right there, drops per minute. We need that drop factor. We need a volume over time, and we've already got that right here. But wait, what about that? Remember, that's a physician order right there. That's It's going to come up in a 1,000 milliliter bag. That's what it's going to be in. And you are already given your volume over time. So in reality, we do not need this number, and I'll show you how that works out. So let's set up our problem. Drops per minute. Start with your drop factor. I have a milliliter, and that's 125 per hour. That's what's going to be running. That's how we're going to do our equation. I don't need hours, but I do need minutes, so I have to throw that on there. Whoops. Minutes. All right. Let me just check and see if my setup is right. I don't need milliliters. I don't need hours. The only thing I'm left with is drops per minute. Now you can go ahead and set your problem up. 20 times 125 divided by 60. And that is going to give us 2,500 divided by 60. And if I get rid of those few zeros, now I can go ahead and just divide a smaller number, 250 divided by 6. And if you do the math on that, you're going to end up with 41.666. Now remember, drops need to be a whole number, but it's already written right here. So we're going to be left with 42 drops per minute. All right, you've stuck with me through this. I'm talking about milliliters per hour and drops per minute. If you have any questions, please make sure you post them in the MDCC discussion forum of your Blackboard course, and have a wonderful day.